Welcome viewers, in this video we will see the 4-bit binary to BCD converter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic 4-bit binary to BCD converter. Binary means zeros and ones having 4-bit. BCD means binary coded decimal. That is also 4 digit. Each and every decimal number is represented by the 4 digits, that is called a BCD converter. That is called BCD, binary coded decimal, right? So the binary number 4-bit binary is now we are going to convert into BCD, right? So the first we will see the input. Input code is nothing but binary code. B0, B1, B2, B3. B0 is the LSB, B3 is the MSB. Now the output code is nothing but BCD code, binary coded decimal. D0, D1, D2, D3, the 4 digits. D0 is the LSB. We have one more digit D4. Why we have the D4? From 0 to 9 we have single digit. 0 to 9 can be represented in a 4 digit BCD number. From 10 onwards, 1 0 means here 2 digits are there. 0 is converted into BCD and 1 is also converted into another BCD. That is 0 represented by 4 digits, 1 represented by another 4 digits. So that is represented by this D4. That is from 0 to 9, D4 is 0. There is only 1 digit. From 10 onwards, in order to indicate 2 digits, from 10 onwards D4 will be 1. Right? So that 1 indicates there are 2 digits are available. Right? So this is a binary BCD output D0, D1, D2, D3. D4 indicates whether it is a single digit or double digit. Right? So because of 4 digit there are 16 combinations available. 2 to the power 4, 16 combination. In that 0 to 9 having only 1 digit, so the D4 will be 0. From 10 onwards, from 10 to 15 having 2 digits, in that D4 is represented by 1. Right? Now we will see the truth table for the relating binary and BCD. Binary is the input and BCD is the output. Right? So the binary code that is represented by the name B3, B2, B1, B0. This is the equivalent decimal number. This is BCD code D0, D1, D2, D3. The D4 indicates how many digits are available. So there are 16 combinations available 0, 0, 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1 like that. So it is simply it is represented the first 4 digit it is 0, 0 from 1, 2, 3, 4. Again we need to repeat 0, 0, 0, 1, 1, 0, 1, 1. Then 0, 1 4 times. Again 0, 0, 0, 1, 1, 0, 1, 1. Then 1 0 like that we can repeat. So from 0 to 9 it is D4 is value is 0. So the BCD also almost similar, same thing only 0 0 0 0 0 0 0 1, right? So 1 2 3 4, first to 4 the D3 and D4 will be 0. Here we can repeat 0 0 0 1 1 0 1 1. Thereby D3 and D2 is 0 1 for next 4 times. Again we have to repeat 0 0 0 1 1 0 1 1. Like that we can repeat. Then 1 0 for this 8 and 9. Again 0 0 0 1. For all the cases D4 is 0. But from 10 onwards we have 2 digits are available. There are 2 digits available. See this 10, 11, 12, 13, 14 and 15. For this we have 2 digits available, so it is represented by 1, right? So the 10 is given as 1 0 1 0, that is 8 4 2 1. 8 4 2 1. 8 and 2 is 1, so that 8 plus 2 10. Here 1 0 1 1. 8 4 2 1. So 8 plus 2 plus 1 11. Similarly 8 4. 8 plus 4 12. 8 4 1 13. So that is represented by the weightage. By the weightage of this number is given as a weightage 8 4 2 1. 8 4 2 1. Right? So for see this last one, all are 1 is there. So 8 plus 4 12. 12 plus 4 14. 14 plus 1 15. So this is normal binary code. But in the BCD, binary coded decimal, how we will represent? 1 is represented by 4 digit, 0 is also represented by another 4 digit. That is called BCD. Every digit is represented by 4 digits. Here not like that. Here directly by using the weightage we can write it, right? In order to send the data for transmitting the data, storing the data, representing the data, we are using BCD. That is, each digit we need 4 locations. For example, 9 means we need 4 location. 10 means for 1 we need 4 location, for 0 we need 4 location. So in order to represent, and also while transmitting, if we have four wires, we can easily transmit. First we can transmit 0, then we can transmit 1. But here is not possible, right? So that we are using the BCD. That is the advantage of BCD. Storing the data, representing the data, transmitting the data, we are using BCD. See, for all this the digit D4 is 1. Now again the 0 is represented 0001. 1 is represented 0001. 2 is represented 0010. So here also we are using 8421 only, but it will go only up to 9. Right. See this 15. This 1 is represented here. Only we need to represent 5. See this, these two are 1. 4 plus 1, 5. Here only 4. Here 2 plus 1, 3. Here only 2. Right. So that is the advantage of BCD. So the binary means by using the weightage we can write like this as it is. But in BCD, every digit is represented by 4 locations, 4 digits. For example, up to 9, 4 digit. 10 onwards, 2 digits are there. So 1 is represented separately, this 0 is represented separately, right? So 1 require 4 location, this 0 require 4 location. Why we are using like this 4? It is represented by 4 location means by storing the data we need each and every decimal we need 4 location. We need 4 wire to transmit the data. We need 4 wire to receive the data. So it will be standardized, right? We are storing, sending the data, receiving the data. It will be very useful if we are represented by BCD. But here not like that. It is given by different value. Now we have the 5 terms are available: D0, D1, D2, D3 and D4. The values are available 1, 0 like that. For this we need to get the Boolean function in order to implement with logic gates, so that binary will be converted into BCD. By using the logic gates we can convert from binary to BCD. So in order to get the Boolean function, this truth table can be, from the truth table we can get the Boolean function using the Karnaugh map. So that we will get the, in Karnaugh map we will get the simplified expression, right? So now we will go to the Karnaugh map to get the simplified Boolean function for these 5 terms: D0, D1, D2, D3 and D4. Now we will go to the Karnaugh map. First we will see the start from D0, right? So this is the 4 variable K map. What is the input? Input is nothing but binary code B3, B2, B1 and B0. This is a binary code. From that we are going to get the BCD code. So B3 and B2 is represented vertically. B1 and B0 were represented horizontally. B3, B2 having 2 variables, so 4 combinations are available: 0, 0, 0, 1, 1, 1, 1, 0. Similarly, B1, B0, 2 variables, 4 combinations are available: 0, 0, 0, 1, 1, 1, 1, 0. Right. So this is the inputs. So from the tabular column, these ones are marked. From the truth table what we discussed earlier, there are 8 ones are available. These 8 ones are marked here. So while going the grouping, we can group these 8 ones, right? All 8 ones are grouped together. In order to get the function, we have to refer the corresponding row: first row, second row, fourth row, third row and fourth row. Similarly, second column and third column. So while referring first row, second row, third and fourth row, this 0, 0 cancelled by 1, 1. 0, 1 cancelled by 1, 0. So all are got cancelled. Only we have to refer the second and third column. So 0, 1, 1, 1. So the first 0 and the first 1 got cancelled because 0 and 1 is cancelled. This second one is available: 0, 1, 1, 1. This one is available commonly. What is that? This one is nothing but B naught. So that D naught value is B naught, right? So this is the input binary code. This is the output BCD code. D naught we can get from the B naught value, right? So we need to implement the logic gates. Using logic gate, we can implement this function. Then we'll go to the D1. D1 having 6 ones are available in the truth table. From the truth table, these 6 ones are marked together. These 2 ones are grouped together. Then these 4 ones are grouped together. So while grouping these 2 ones, we have to refer the corresponding third row. What is available in third row? 1 1. 1 1 means B3 B2, B3 B2. We have to refer first column and second column. 0 0 0 1. Right. So the second 0 and second 1 got cancelled. This 0 is available commonly. First 0 is available in commonly. First 0 means B1. Right. 0, because of 0 it is B1 dash. So it is B3 B2 B1 dash. Now we'll refer these 4 zeros. Corresponding first row and second row we have to refer. What is available here? 0 0 0 1. Right. So the first 0 available commonly, that is nothing but B3. B3 bar because of 0. This second 0 and 1 got cancelled. This 0 and 1 got cancelled. Similarly, you have to refer the third column and fourth column. 1 1 1 0. This 1 is available commonly. The first one. First one is nothing but B1. Right. B3 dash B1. The second 1 and 0 got cancelled. So the expression for D1 is B3 B2 B1 dash plus B3 dash into B1. Similarly, we will go to D2. Next, we will go to the value D2. For D2, there are again 6 ones are available. These 4 ones are grouped together. These 4 ones are grouped together. So while grouping these 4 ones, we have to refer the corresponding second row. 0 1. 0 1 means B3 dash B2. 0 means B3 B3 dash. So B3 dash B2. So the corresponding columns, all 4 columns are available. So the got cancelled. 0 0 cancelled by 1 1. 0 1 cancelled by 1 0. Now we have to refer these 4 ones. The corresponding second row and third row. In second and third row, this 1 is available commonly. This 0 and 1 is cancelled. This one. What is this one? Second one means B2. Similarly, third column and fourth column. This first one is available commonly. What is first one? B1. Right. So B2 into B1. The second 0 and 0 is here 1 and here 0 is available. So the got cancelled. 1 and 0 got cancelled. So that the D2 value is B3 dash B2 plus B2 B1. Similarly, we will go to the D3. So D3 having only 2 ones are available. So the what is available corresponding row 1 0. 1 means B3. 0 means B2 dash. B3 B2 dash. What is available in the column? 0 0 0 1. First 0 available in both the column. First 0 means B1 dash. Second is 0, here 1. So got cancelled. So that here it is available B3 B2 dash B1. The expression for D3 is B3 B2 dash B1. Now we have one more term. D4 is available. D4. So D4 also having 4 ones are available. So these 4 ones are combined together, grouped together. These 4 ones are grouped together. So while grouping these 4, we have to refer the corresponding third column, third row. Third row is 1 1. 1 1 means B3 B2, B3 B2. The corresponding columns are got cancelled. So while grouping these 4 ones, we have to refer third row and fourth row. So this first one is available commonly. First one means B3. Second 1 and 0 is there, got cancelled. Similarly, the third column and fourth column. The first one is available. 1 is available commonly. 1 means B1. Right? B3 into B1. The second one here 0 available. So this 1 and 0 got cancelled. So the D4 expression for D4 is B3 B2 plus B3 into B1. Now we got the expression for all 5 D4, D3, D2, D1 and D0, that is binary coded decimal BCD code. Now these Boolean functions should be implemented with the logic gates. Now we'll go to the logic gate. So this is the logic gate available. First we'll see the inputs. What are the inputs are available? This is the binary codes input. This is the BCD output. So binary code what we have B3, B2, B1 and B0. From B3 the tapping is taken and is connected to NOT gate. So that we got B3 dash. Similarly, B2, one more NOT gate. So we got B2 dash. B1, one more NOT gate is connected, B1 dash. B3 is not needed. B3 dash is not needed. Right. So we have B3, B2, B1 and B0. By using NOT gate, we have B3 dash, B2 dash and B1 dash. Right. So first BCD code D0. D0 is nothing but B0. From the Karnaugh map, we simplified the expression D0 equal to B0. So from B0, we can get the BCD output of D0. Then D1. What is the value of D1? Is nothing but the B3, B2, B1 dash plus B3 dash into B1. We have to add these two terms. This addition is done by this OR gate. How to get B3, B2, B1? By using the AND gate. Here B3 is connected. B3, B2 and B1 dash is connected. These three terms are connected, so it will multiply. Similarly, here B3 dash is connected and B1 is connected. So we got these two terms using this AND gate. These two terms are added by this OR gate. So that we got the value of D1. That is a binary coded decimal, the second digit D1. Now we'll go to D2 and D3. D2 and D3. So the D2 is nothing but B3 dash B2 plus B2 into B1. Right. So these two are added by this OR gate. How to get B3 dash and B2? By the AND gate. This B3 dash and B2 is connected, so we got this value. Similarly, here B1 and B2 is connected, so we got this value. These two are added by this AND gate. Then D3 is only one term is there. B3, B2 dash, B1 dash. Right. So by using the AND gate, B3 is connected, B2 dash is connected and B1 dash is connected. All three are multiplied. So we got D3 value. Right. So we got the BCD output D0, D1, D2 and D3. We have one more term D4 is available in order to indicate whether how many digits are there, MSB. Right. So that is nothing but B3, B2 plus B3, B1. These two terms are added by this OR gate. How to get B3, B2? By using one AND gate. Here B3 and B2 is connected, so we are getting B3, B2. Here B3 and B1 is connected, so we are getting B3 into B1. These two are added by this OR gate. So finally we got D4, this MSB. Right. So D0, D1, D2, D3 as a output of the binary coded decimal BCD, and also we got the MSB D4 also. So in this video, we discuss about how to convert binary to BCD. BCD means binary coded decimal. Each decimal is represented by 4 digits. From 0 to 9 is a no problem. We are having only one digit. From 10 to 15, 2 digits are there. So that we have one more term called D4. So the D4 will be 1 for the value 10 to 15. Then we framed the truth table. From the truth table, by using the K map, we got the simplified Boolean expression. That Boolean expression is implemented with the logic gates, so that we can get the binary code to BCD code. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. In this video, we will see the 8421 BCD to XS3 code converter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. It's a code converter, that is BCD to XS3 code converter. We will see the what is the truth table, what is the logic diagram, how to convert the BCD to XS3. What is the logic circuit for that? We are going to develop the logic circuit for this converter. So the XS3, first we will see what is meant by XS3 code. XS3 code is a modified form of a BCD number. The XS3 code can be derived from the natural BCD code by adding 3 to each coded number. So XS3 means very simple. With the BCD, we need to add the 3. By adding 3 with BCD, we will get the XS3 code. Right? So this code is used for transmitting the data representation for other purpose. That's why we are adding 3 with BCD to get the XS3 code. For example, the decimal number 12 can be represented in a BCD as 0010010. That is by using 8421 weightage. 8421, right? The last digit is 1 means it is 1. 8421, right? The second digit is 1 means it is 2, right? So 1 is represented separately by 4 digits, 2 is represented by the 4 digits separately by using the weightage 8421. So excess 3 means with this 1 we have to add 3. 1 plus 3 become 4. 2 plus 3 become 5, right? So 45. So excess 3 code for a decimal number 12 in a BCD is nothing but 45. Now 4 is represented separately, 0, 1, 0, 0. Then 5 is represented as 0, 1, 0, 1, right? So here we are using the weightage 8421. Here also 8421. See, this the second digit is 1 mean it is 4. Here second and fourth digit. So that 2, 4 plus 1, 5. Right? So it is represented by the weightage 8421. So excess 3 code means with the decimal number by adding 3, what we got is the excess 3 code. For example, 12 means 1 is added with 3, so it become 4. 2 is added with 3, it become 5. Again, after that, the 4 is represented separately by 4 digits. This 5 is represented by the 4 separately by the 4 digits using the weightage 8421, right? So now it is very clear. BCD to excess 3 means with that BCD we need to add the decimal number 3. Then with that added value we need to again represented by the BCD code using the weightage 8421, right? Now we'll see this input code. What is the input code? Is nothing but BCD code. We'll take D3, D2, D1, D0. D0 is the LSB, D3 is the MSB, least significant bit, most significant bit. Then the output code is excess 3 code. So we'll represent it as E3, E2, E1 and E0. So E0 is the LSB, E3 is the MSB, right? So now we have assigned the input code and output code. Input code is represented by the D. Output code is represented by E. Now we'll see the truth table so that we can develop the logical expression. From that we can develop the logic circuit. Now we'll go to the truth table. So this is the decimal equivalent 0 to 9. So that is represented by the BCD code. So this is the input. This is the output. Right. So this BCD code again it is represented by 8421 representation. Since the excess 3 also represented by 8421 weightage. Right. Now we'll see that. First we'll see the input. The decimal 0 to 9. Right. The 0 is represented 0, 0, 0. 1 is represented, the last digit is 1. Right. 2 is represented by second digit is 1. 3 is represented by second and third. 2 plus 1, 3. So that 0, 0, 1, 1. 4 is represented by this third digit. I am telling from the MSB. Third digit is 1. So that 0, 1, 0, 0 means 4. 5 is represented by this 4 and 1. That is first digit and third digit. First digit and third digit 0, 1, 0, 1. So we'll get 5. So like that it is represented. By using the weightage 8421, we are representing the BCD. It's a normal one. Normal BCD number is represented. Then what is excess 3 in decimal? First we'll see the decimal, then we'll go to the code, BCD code. So 0 plus 3 is 3. With the 0, we are adding 3. 1 is added with 3 from 4. 2 plus 3, 5. 3 plus 3, 6. 4 plus 3, 7. Like that we are adding. Now the excess 3 code is become 3, 4, 5, 6 up to 12. Right here from 0 to 9 is there. While adding 3 it become 3, 4, 5 up to 12 is available. Now this bracket, what is the number what is available in the bracket is the excess 3 in the decimal. That number should be represented in the binary code, BCD code, right? So the 3 means 0, 0, 1, 1. That is this one is 2, this one is 1. So 2 plus 3, 2 plus 1, 3. Then 4. Here 4 is available. So that this digit is 1. So that 0, 1, 0, 0 means 4. Right. 5. How will you get the 5? Second and third. So I am telling from MSB. Second and third, second and last. If you put second and last is 1. Second and last is 1. What is the value? 4 plus 1, 5. Right. Then how will you get 6? Second and third. 4 plus 2, 6. Right. So 0, 1, 1, 0. If you put 0, 1, 1, 0, what is the meaning? This 4 plus 2, 6. So like that we can represent the other values up to 12. How will you represent 12? 12 means 8 plus 4, 12 is there. So 1, 1, 0, 0. 1, 1, 0, 0. 1 means this is 8, this will be 4, remaining 0. So 8 plus 4, 12. Right? Now this is the equivalent XS3 code. Right? So these two column is the input code BCD. It is a decimal, then equivalent BCD. These two column refer the output code XS3 code. XS3 code in decimal, that is 0 is added with 3, 1 is added with 3, so that we got the XS3 code in decimal. It is available in a bracket. The number available in bracket is the XS3, that is again represented by the XS3 code by using the weightage 8421. Now we need to develop the logical expression for this E0, E1, E2, E3. Then that logical expression should be implemented with the logic gates, so that we'll get the input decimal to output XS3 code. Now we'll go to the Karnaugh map. By using the Karnaugh map, we can obtain the simplified form of the Boolean function for E3, E1, E2 and E0, E1, E2 and E3. Right? Wherever 1 is available, it is marked as 1. Wherever 0 available, it is marked as 0. For example, in E0, 1, 2, 3, 4, 5. 5 ones are available. In E1, 1, 2, 3, 4. Here also 5 ones are available. In E2, 1, 2, 3, 4. 5 ones are available. E3, 1, 2, 3, 4, 5. So everywhere 5 ones are available. These 5 ones are represented in the K map and will get the simplified form of Boolean function. That function can be implemented with the logic gates. So now we'll go to the Karnaugh map in order to get the simplified form of Boolean function for E0, E1, E2 and E3. First we will see the Boolean function for using the K map for E3. First we'll go for E3. Right? So this is the 4 variable K map, because input what we have 4 variables are available, D3, D2, D1 and D0. This is nothing but the BCD code. E3, E2 is the XS3 code. So we are converting from BCD to XS3. For that only we are going to obtain the Boolean expression. Right? So the input code is D3, D2, D1, D0. D3, D2 represented in a vertical manner, D1, D0 represented in a horizontal manner. It is a 4 variable K map. So D3, D2 means 2 variables, so 4 combinations are available, 0, 0, 0, 1, 1, 1, 1, 0. The third and fourth row is interchanged. Similarly, D1, D0, 2 variable having 4 combinations, 0, 0, 0, 1, 1, 1, 1, 0. Here also third and fourth column is interchanged. That is the nature of the K map. Right. So in this K map, we need to represent the numbers available is marked as 1. That is for E3 we already discussed. There are 5 ones are available. So this 1, 2, 3, 4, 5 ones are available. So from 0 to 9, we convert 0 to 9, we are having the code. From 10 to 15, the code is not available. So that is not needed. So that is taken as a don't care condition. Right? That these 6 are don't care condition. From starting from 10 to 15, the 6 numbers are available. Right? These are all the don't care condition. So in the K map, we can represent the min term directly. That is, this is 0, 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11. This is nothing but 10. This is 11. 12, 13, 14, 15. Right? So 10, 11, 12, 13, 14, 15. These are marked as a cross mark. That is nothing but don't care condition. Right? By using min term, I am explaining using the min term. This is nothing but 10, 11, 12, 13, 14, 15. So these 6 numbers are marked as don't care condition. Right? So there are 5 ones available, that is we analyzed from the truth table. Remaining 6 are, that is from 6 to 10 to 15 as a don't care condition. Right. Now by grouping this grouping this cell, we can obtain the minimized expression. Right. First we will see any 8 grouping of 8 possible cells are available. So first we will see 8, then 4, then 2. So here 8 possible cells are available, grouping of 8 cells. So this don't care condition, while grouping we can use it, but it is not necessary to group all don't care condition. Right? If it needed, we can use the don't care condition. Otherwise we can leave it. So there two ones are available. Here the don't care conditions are available. So we are using all these don't care conditions to group the 8 cells. Right? We are grouping all 8 cells. So while grouping this 8 cell, we have to refer the corresponding third row and fourth row. Similarly, first column, second column, third column and fourth column, because this grouping covers all 4 columns and this third and fourth column. So while covering all 4 columns, 0 0 cancelled by 1 1, 0 1 cancelled by 1 0, because here 0, here 1, here 1 0, here 0 0 1 1, all are cancelled. Only this we have to refer third and fourth row. What is available in third and fourth row? 1 1 and 1 0. See, this 1 is available commonly from third and fourth row. Here 0 1 is available, here 0 is available, second number, that got cancelled. So only the first number is 1 available in both third row and fourth row. What is this one? 1 is nothing but D3, right? So this is the D3. While grouping 8 cell, what we got? D3, right? Now we'll go to another 2 groupings are available. These two 4 cells are grouped and these 4 cells are grouped together. So while grouping, first we'll see this grouping of 4 cell, green color, right? So we have to refer the second row and third row, second column and third column, right? What is available in second row and third row? 0 0 1 1. See, this first one is 0, second here, the first number here 0, here 1, got cancelled. Second number is 1, available in both the second row and third row. So the second number 1 is commonly available. First number got cancelled. What is second number? It is D2. So we'll write it as D2, right? Now we have to refer the corresponding the second row and third row, second column and third column. Here 0 1 available, here 1 1 available. So the first number 0, here 1 got cancelled. Second number 1 available in both second column and third column. What is the second number? D0. So this is D0. D2 into D0. So by grouping these 4 cells, green color, what we got? D2, D0. Now we'll go to the grouping of these 4 cells represented by the blue color. So again, similarly, we have to refer the second row and third row. So what we got? D2. Well, it's the same thing. The grouping of this cell is very similar to this cell for referring third row and fourth, second row and third row. There we got D2. Here also D2, same thing, we got D2. Only this third column and fourth column is differ. What is available in third column? 1 1. Fourth column 1 0. So the first number available commonly. What is first number? D1. So it is D1. Second number here 1, here 0. Go got cancelled. So 1 is got cancelled by 0. So it is D1, right? So for this green color, what we got? D2, D0. For blue color, we got D2, D1, right? So this is nothing but D3 plus D2, D0 plus D2, D1. The D2 available commonly, so taken commonly. So we get D0 plus D1. So finally we have D3 plus D2 of D0 and D1. So that is the expression for E3. Now we'll go to the E2, right? Again, so these 6 cells are don't care condition, 10, 11, 12, 13, 14, 15. So other 5 ones are available. Already we discussed in the truth table. So 1, 2, 3, 4, 5. These 5 ones are marked together. Now we'll go for the grouping, right? So first we'll see group these 2 cells. There is no other possibilities. The second grouping is these 2 cells and these 2 cells are grouped together. So grouping of 4 cell. Similarly, these 2 cells and these 2 cells are grouped together. That is grouping of 4 cells, right? So first we'll see the grouping of these 2 cells. What is this? How to refer this? We have to refer the second column and second row and third row. What is second row and third row? 0, 1, here 1, 1. So the first 0 is available, here 1 is available, first number, so got cancelled. Second number is 1, 1. What is second number? D2. So we'll write it as D2. Same thing what we discussed here also. Second row and third row means D2, right? So correspondingly, what is available in first column? 0, 0. 0, 0 means D1, D0. That is D1 bar, D0 bar. D1 bar and D0 bar, right? So while grouping these 2 cell, what we got? D2, D1 bar, D0 bar. So grouping, while grouping 8 cells, we'll get only 1 variable. While grouping 4 cells, we'll get 2 variables. While grouping 2 cells, we'll get 3 variables. it keep on increases, right? Now we'll go to the next one. First we'll refer this red color, these two cells and these two cells. So we have to refer the first row and last row. Similarly, second column and third column. What is available in first row? 0, 0. Here 1, 0. So the first number here is 0, here 1, got cancelled. Second number is 0, here also 0. That is commonly available. What is second number? D2. That means D2 dash. Right. Then what is available in second row, second column and third column? 0, 1, 1, 1. So the first number here 0, here 1, got cancelled. Second number is 1, available in both the column. What is second number? D0. So D2 dash, D0. Right. So by grouping this red color 4 cells, what we got? D2 dash and D0. Then we'll go to this blue color. These two cells and these two. Again we have to refer the first row and last row. While referring first row or last row, what we got? D2 dash. We already discussed with the red color. So here also D2 dash. Only this third column and fourth column we have to refer. In red color we refer second and third column. Here third column and fourth column. What is available? 1, 1, 1, 0. So the first number 1 is available in both the column. The second number here 1, here 0, got cancelled. So the first number is nothing but D1. So what we got? D1. So the final expression is D2, D1 dash, D0 dash plus D2 bar, D0 plus D2 bar into D1. The D2 available commonly is taken outside. So D0 plus D1. Now we got the expression for E2. Now we'll go to the expression for E1 and E0. E3 and E2 is completed. We'll go to E1 and E0. So for E1, again we discussed these three are don't care condition. The other 5 ones are available. So 1, 2, 3, 4, 5. These 5 ones are marked together. Right. So here what we are doing, these 4 cells are grouped together and these 4 cells are grouped together. So this don't care condition while grouping we can use, but the no need to group the don't care condition. It is not necessary to group all don't care conditions. Right. Here we are require, so we are using this don't care condition. Here also we are require, so that these two don't care condition we are using. But these 3 are not covered, so it is not necessary to cover all don't care condition. Right. So while grouping these 4 cells, we have to refer first column, first row, second row, third row and fourth row. Then first column. So while referring row, first row, second row, third row, all are cancelled. 0, 0 cancelled by 1, 1, 0, 1 cancelled by 1, 0. So we have to refer only the first column. First column 0, 0. What is that? D1, D0. That is D1 dash, D0 dash. Because of 0, 0, D1 dash and D0 dash. Similarly, here this grouping of these 4 cells. Again we have to refer the all rows. They got cancelled. Only we have to refer the third column. Third column is 1, 1. 1, 1 means D1, D0. Right. So here we have D1 dash, D0 dash. Here D1, D0. What is this? This expression is nothing but the exclusive NOR gate. D1 exclusive NOR of D0. By using the single exclusive NOR gate, we can implement the function E1. Right. Because it is clearly available as a exclusive NOR gate function. Now we'll go to the E0. So these 6 are don't care condition. Other 5 ones are available. 1, 2, 3, 4, 5 ones are marked together. Here these 4 cells and these 4 cells are grouped together as a 8 cell, grouping of 8 cell. That is right and leftmost corners. Right. There is a grouping of 8 cells. While grouping of 8 cell, we have to refer this corresponding row. So corresponding row got cancelled. Then we have to refer the corresponding column, first column and last column. What is available here? 0, 0, 1, 0. So the first number here is 0, here 1. So got cancelled. Second number is here also 0, here also 0. So only we have to refer the second number. What is second number? D0. 0 means D0 dash. So E0 equal to D0 dash. Right. So now we got the expression for E3, E2, E1 as well as E0. Now we'll go to the logic diagram to implement this E3, E2, E1 and E0. So this is the logic diagram available. This is the input code, BCD code. Here we are going to get the XS3 code. So that we are converting from BCD code to XS3 code. So BCD code is represented by D, D3, D2, D1, D0. This line having the input D3. Similarly, D2, D1, D0. In order to get the D3 dash, one AND gate, NOT gate is connected. From D3 the tapping is taken and one NOT gate is connected. So that we got D3 dash. Similarly, we have another in every line NOT gate is connected, so that we got D2 dash, D1 dash and D0 dash. So totally there are 8 possible inputs are available. D3, D2, D1, D0. These lines are represented. While connecting NOT gate, we got D3 dash, D2 dash, D1 dash and D0 dash. So all possible 8 inputs are available here. So whichever is needed, we can connect to the logic gates, right? So this is the XS3 code. First we start from E0, LSB. So E0 is nothing but D0 dash. We already discussed in the K map. So we are connecting with the D0 dash, right? So here we got the XS3 code, LSB value E0, right? What is E1? E1 is nothing but XNOR gate of D1 and D0. That also we discussed in the K map, right? So the D1 is connected here. D1 is connected and D0 is connected to XNOR gate, so that we got the output of the digit D1, right? Now we'll go to the E2 and E3, right? E2 and E3 having the more variables. First we'll see the E2. So here one OR gate is available. OR gate means it will add. That is connected with another 2 AND gates, right? So this AND gate is connected from this one input and another AND gate. So this AND gate having D1 dash and D0 dash. This one is nothing but D2 dash, right? So these two are now multiplied together. D2 dash, D1 dash, D0 dash. So this is the one of the required input, right? D2 dash. So this is connected with the OR gate. Another input to this OR gate is this one, D2 dash of D1 and D0. So that is obtained from this OR gate and AND gate, right? So while connecting all these three, we got E2. That is nothing but D2 dash, D1 dash, D0 plus D2 of D1 plus D0. So this is the expression what we got in the K map. So here is a small correction. This is not a D2 dash, it is D2, right? So here it is connected to D2 only. D2, not a D2 dash. In K map also what we have, it is D2, right? So D2, D1 dash, D0 dash is available in this AND gate by using 2 more AND gates. This D2 dash of D1 and D0 is available in this AND gate by using one OR gate and AND gate. We got this. These two are added together by the one more OR gate. So now we got the value of E2. Now we'll go to the E3. What is the value of E3? Is nothing but the sum of these two, D3 plus D2 of D1 plus D0, right? So this OR gate will add these two functions. D3 is connected directly. How will you got D2 of D1 plus D0? This D2 is connected here. This D1 and D0 is available in this OR gate, so that is connected. This D1 plus D0 is commonly available for D2 as well as D3. So we are using this output commonly to the E3 as well as E2, E2 as well as E3, right? So by adding these two, we got the value of E3. So in this video, we discuss about how to convert the BCD to XS3 code. First, we discuss the truth table. From the truth table, by using the Karnaugh map, we got the simplified Boolean expression. Then that Boolean expression is implemented with the logic gates. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Viewers, in this video, we will see the XS3 to BCD code converter. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, XS3 to BCD code converter. What is XS3 code? From the BCD code, by adding 3, we will get the XS3. XS3 means we have to adding 3. For the normal BCD, by adding 3, we will get the XS3 code. Now we are going from XS3 to BCD. So that we need to subtract 3 from the XS3, so that we will get the BCD code, right? So BCD to XS3 available in separate video. Here XS3 to BCD. So we'll assign the input code. Input code is the XS3 code assigned as E3, E2, E1 and E0. E0 is the LSB, E3 is the MSB. The output code is BCD, that is represented as D3, D2, D1 and D0. D0 is LSB, D3 is the MSB. Right. Now we'll form the truth table, that is from converting from XS3 to BCD, so that we'll got the truth table value. From the truth table we can frame the minimized Boolean function, then that Boolean function will be implemented with the logic gates. Right. Now we'll go to the truth table for converting XS3 to BCD code. Right. So what is XS3 and what is BCD? First we'll see in the reverse order. By BCD, if we add 3, we will get the XS3. XS3 means adding 3. From 0, if we add 3, you will get XS3 decimal. This is the normal decimal number. This is a decimal number equivalent to XS3 code. So 0 plus 3, we will get 3 here. 1 plus 3, 4. 2 plus 3, 5. So that is the process to convert BCD to XS3. Now what we need is XS3 to BCD. So we need to subtract here. 3 minus 3, 0. 4 minus 3, 1. 5 minus 3, 2. Right? Minimum we start with 3. We cannot start with this 2 or 1. So while subtracting we will get negative value. So the minimum XS3 code will be 3. Starting value is 3. 2, 1, 0 will give negative value. So it is from 3 to 12. Right? From each digit the 3 is subtracted. So that we will got 0 to 9. Right? 12 minus 3 is 9. Right? 9 minus 3 is 6. Right? So this is the equivalent decimal of XS3 code. This is the decimal equivalent of a BCD code, that is subtracted. 3 is subtracted. Then this is 3 is represented by the code weightage of 8421. This is 8421 weightage. So here also 8421 weightage will be available, right? So 3, how will you represent 3? So here the third and fourth digit is there. 2 plus 1, 3. By adding third and fourth digit, we will get 3. So that 0, 0, 1, 1. Third and fourth digit is make it as 1. How will you get the 4? The second digit is 4 is available. So that is make it as 1. Remainings are 0. So that we will get 4. How will you get 5? So here the second and fourth digit. So here 4 is there, here 1 is there. By adding 4 plus 1, we will get 5. So the second digit and fourth digit will be 1. Remainings are 0. So that 4 plus 1, 5 will get. So like that these are assigned together. This is a normal BCD. This already available. It's a standard form 8421. So by using that from 3 to 12 it is assigned. The same thing is followed here also for 0 to 9. Right? 0 means all are 0, 0. How will you represent 1? Here 1 is available. Fourth digit is 1. So by making the fourth digit is 1, we will get the value of 1. Then how will you get a 2? This third digit is 2 is there. So we will make it as 1. So that we will get 2. 3. How will you get 3? Third and fourth digit. 2 plus 1, 3. So we will make it as third and fourth digit as 1. So that we will get 3. How will you get 4? So second digit is 4 is available. So we will make it as second digit is 1. So we will get the equivalent of 4. How will you get 5? The second and fourth digit. 4 plus 1 is 5. So then make it as second and fourth digit is 1. So we will get the value of 5. So like that it is represented. Right. So now we have the truth table converting the XS3 code to BCD code. Right. Now for this BCD code D0, D1, D2, D3, we need to frame the minimized Boolean function by using the K-map. Here the values are available. These values are plotted in the K-map. By grouping the cell, we need to get the minimized expression for D3, D1, D2 and D0, D1, D2 and D3. That from the minimized expression we can implement with the logic gates. Right? See this, the D0, 1, 2, 3, 4, 5 ones are available. In D1, 1, 2, 3, 4 ones are available. In D2, 1, 2, 3 ones are available. In D3, 2 ones are available. So here 2 ones, 3 ones, 4 ones and 5 ones. Right? Keep on increasing. So these value we need to plot in the K-map. Now we'll go to the K-map. Right. First we'll see the D3. Then we'll go to D2. D3. So this is the output code, BCD code. The input is nothing but the XS3 code. E3, E2, E1, E0. These four values are taken as a input. E3, E2 represented vertically. E1 and E0 represented horizontally. E3 and E2, two variables, so four possibilities are available. This is the 8 variable came up 0, 0, 0, 1, 1, 1, 1, 0. E1 and E2 also two variable having four possible combinations 0, 0, 0, 1, 1, 1, 1, 0. There is a interchange between third and fourth column, similarly third and fourth row. Right. Now we need to mark the ones available in the truth table. For D3 we already discussed only two ones are available, this one and this one. Right. What about this cross mark? That is nothing but a don't care conditions. The don't care condition means we are having 3 to 12 in the XS3 code. 0, 1, 2 is not taken into account, right? So this is nothing but 0, this is 1, this is 2, right? So the XS3 code starts from 0 to 3 to 12 only, right? We'll refer the diagram. So from 3 to 12 only the tabular column is available. 13, 14, 15 is not available. Similarly, 0, 1, 2, 3 is not available, right? So similarly, nearly 6 variables are not available. Here 3 variables not available. Here also 3 variables not available. 13, 14, 15. Here 0, 1, 2, 0, 1, 2 not available. So that are taken as a don't care conditions. These 6 variables are taken as don't care condition. So by using the min term, this is represented 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is the min term representation. Based on that, this is 0, 1 and 2. These three are marked as cross mark, don't care condition. Similarly, we have 13. This is 13, this is 14, 15. 13, 14, 15 also marked as cross mark, don't care condition. Right. So now we have two ones are available. We need to group these two ones. So one possibility is these 4 cells are grouped together and these 2 cells are grouped together. So the don't care condition while grouping we can use that. We can use the don't care condition while grouping, but it is not necessary to group all don't care conditions. These don't care conditions are not grouped together, so it is not necessary. So while grouping one, we can use the don't care condition, but the don't care conditions are not covered, it's not a problem, right? First we will see grouping of these 4 cells. So while grouping 4 cell, we have to refer the corresponding third row. What is available in third row? 1, 1. What is 1, 1? E3, E2. We have to refer the corresponding column, first column, second column, fourth column, but all are cancelled. 0, 0 cancelled by 1, 1, 0, 1 cancelled by 1, 0. So all are cancelled. Only we have 1, 1, that is E3, E2. Then grouping of these 2 cells. We have to refer the corresponding third row and fourth row. What is available in third row? 1, 1. Fourth row? 1, 0. So the first number 1 is available commonly. What is first number? E3. This E3 is there. Second number is 1, 0. 1 and 0 got cancelled. Similarly, what is available here? 1, 1. What is 1, 1? E1 and E0. E1 and E0. So that E3, E1, E0. Right? So this is the equivalent expression for D3. Now we'll go to D2. Right? Here also there are 6 variables are marked as don't care condition. D2 having the 4 ones are available. 1, 2, 3, 4 ones are available. Now we'll go for the grouping. These 2 ones are grouped together. Right? These 2 ones and these 2 ones, top and bottom. 1, 2, 3. These 2 ones. These are grouped together. So after grouping, this one is also available. All 4 corners are grouped together. So there are 3 groupings available. This is grouping of these 2 cells. First grouping. Second grouping is grouping at the all 4 corners in order to cover this one. In order to cover this one, these 2 cells and these 2 cells are grouped together. Top and bottom. Right. First we will see the grouping of these 2 cells. So we have to refer the corresponding second row and third row. What is available in second row? 0, 0. Here 1, 1. So the first 0 and first 1 is cancelled. The second number 1 is available commonly in both second and third row. What is second number? E2. So it is represented E2. What is available corresponding column is 1 1. 1 1 means E1 E0. So E2 E1 E0, right? So that is the expression due to grouping of these two cells. Now we'll go to the grouping of corner cells, all four corners. So all four corners we have to refer the corresponding first row and last row. Here 0 0 1 0. So the first number here 0, here 1 got cancelled. Second number is 0 available commonly in both first row and last row. What is 0? Second number, what is second number is E2. E2 means 0 means E2 dash, right? We have E2 dash. So correspondingly we have to refer the first column and last column. What is available here? 0 0 1 0. So the first number here 0, here 1 cancel. Second number 0 is available in both the case. What is second number? E0. E0 means E0 dash. So this is the equivalent to the grouping of corner cell, E2 dash and E0 dash, right? Now we'll see the grouping of these four cells, red color. So again we have to refer the first row and last row. We already see that it is E2 dash, right? Similarly we have to refer first column and second column, 0 0 0 1. First number 0 commonly available, second number 0 1 cancel. What is first number? E1. 0 means E1 dash, right? So E2 dash E1 dash, right? Here E2 dash E0 dash. So finally what we have? E2 E1 E0 plus E2 dash E1 dash plus E2 dash into E0 dash. Now we'll go to the remaining, this D2 is there. Now we'll go to D1 and D0, simplified expression for D2 and D0. So the D1, we already discussed the D1 having 4 ones, 1 2 3 4. These 6 are don't care conditions. So these 4 cells are grouped together. Similarly these 4 cells are grouped together. While grouping these 4 cells, corresponding rows are cancelled. Only we have to refer the corresponding column. 0 1. 0 1 means E1 dash E0. 0 means E1 dash. 1 means E0. E1 dash E0. And grouping of these 4 cells, again corresponding rows are cancelled. Only this column is available. 1 0. 1 means E1. 0 means E0 dash. So E1 E0 dash, right? So grouping, while grouping this cell we have E1 dash E0, while grouping this cell we have E1 E0 dash, E1 dash and E0 dash, right? Okay. Now we'll go to D0. So D0 having 5 ones, 1 2 3 4 5s are marked together. These 3 6 are don't care condition. So here we are grouping 8 cells, these 4 and these 4, right and leftmost corners, right? So grouping of 8 cell. While grouping 8 cell we will get the minimized function, right? So we have to refer this corresponding row, all are cancelled. Only we have to refer the corresponding column, 0 0 1 0. The first here 0 is available, here 1 is available, cancel. Second number is here also 0, here also 0. Second number means E0, 0 means E0 dash, right? So we got E0 dash. So for D1 we got E1 E0 dash plus E1 dash E0. D0 is E0 dash. So now we got the expression for D3, D2, D1 and D0. Now we'll go to the logic diagram to implement these 4 functions. Now we'll go to the logic diagram. So this is the input code XS3 code. This is the output one BCD code, converting from XS3 to BCD code. So XS3, all 4 possible E3, E2, E1, E0, all 4 possible inputs are available. So these line represent the input E3, E2, E1 and E0. In order to get the E3 dash, one NOT gate is connected. From E3 the tapping is taken and is connected with one NOT gate, so that we'll got E3 dash. Similarly we have E2 dash, E1 dash, E0 dash by connecting the NOT gate. So there are 8 possible inputs are available here, E3, E2, E1, E0, E3 dash, E2 dash, E1 dash and E0 dash. So which one we are required, we can connect as per our requirement, either this value or this value, right? Now we'll go to the D3. So the D3 is nothing but sum of these two, right? E3 E2 plus E3 E1 E0, right? These two are added by this OR gate. How will you get this E3 E2? By using AND gate. So here E3 and E2 is connected, so it will give E3 into E2. So this AND gate, this function is got by AND gate, So we are going in a reverse order. E3, E1, E0 is connected. This is E3, E1, E0 is connected. So we got this function. So these two are added by this OR gate. So we got the value of code of D3, that is MSB. Then we'll go to the D2 value. How will you get the D2? D2 having three functions. These three are added by this OR gate. These three functions got by the three AND gates. E2, E1, E0. One AND gate is E2, E1, E0 is connected. Another AND gate E2 dash and E1 dash is connected. E2 dash, this is E1 dash. In another AND gate E2 dash and E0 dash is connected. So we got this value. These three values are added by this OR gate. So that we got D2. Then we'll go for D1 and D0. D1 having two functions, two terms, that is added by this OR gate. How will you get this function? By using the AND gate. E1 and E0 is connected. E1 and E0 is connected. Here E1 dash and E0 is connected. So that we got this value. These two are added by this OR gate. So that we got D1. D0 is nothing but E0 dash. So directly it is connected. This is the LSB value. LSB of the BCD code. So now we got from these lines are XS3 code. So by connecting the logic gates, we got the BCD codes D3, D2, D1 and D0. In this video, we discuss about the how to convert XS3 code to BCD code, right? So we discussed the truth table followed by simplification of Boolean function using K-map. That simplified expression is implemented with the logic gates. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Viewers, in this video we will see the BCD to gray code converter. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic BCD to gray code converter. We need to convert the BCD code into gray code by using the converter. We need to develop the logic diagram. First we will see how to convert the BCD to gray code. Let us consider this BCD code 1001001. This is the BCD code. How to convert this gray code? This is the resultant gray code. Write the first digit as it is. Then perform the XOR operation between first and second digit. Write the result as it is. Then perform the operation between second and third digit and write the result. Like that we need to perform the XOR operation between the digits. Then what is the XOR operation? We'll see what is the XOR operation. XOR gate. This is a input A and B, output C, right? So the input A and B having four combinations 0 0 0 1 1 0 1 1. If it is 0 0, the output will be 0. 0 1 means 1, 1 0 means 1, 1 1 means 0. So from this truth table, so we can say that if the inputs are equal 0 0 or 1 1 means the output is 1. The inputs are different 0 1 or 1 0 means the output will be 1 high, right? So for the same input the output will be low, for different input the output will be high. So this is the nature of the XOR gate. So based on that we can now perform the XOR operation, right? So the BCD code is 1001001. So this 1 is written as it is. For a gray code 1 is written as it is. Then perform the XOR operation between 1 and 0. 1 and 0 mean different, both are different. 1 and 0, both the inputs are different. So the output will be 1. Then 0 0, XOR operation between 0 0, both are equal means the output will be 0. Then 0 1, again the inputs are different, so that the output will be 1. Then 1 0, again the outputs are different, so the output will be 1. Then 0 0, both the inputs are equal, so the output will be 0. 0 1, inputs are different, so the output will be 1. So this is the process to convert BCD code to gray code, right? So the resultant gray code is now 11011101, right? So this is the process to convert BCD to gray code, right? So they are using the XOR gate. XOR gate nature is both the inputs are equal, the output is 0. Both the inputs are different, the output will be high. So based on that we are performing first digit written as it is, first and second digit we are performing the XOR gate, the resultant we are writing, right. So based on that we got this. So the input code is the BCD code. Let us consider D0, D1, D2, D3. D0 is the LSB, D3 is the MSB. The output code is nothing but gray code, G0, G1, G2, G3, right. G0 is the LSB and G3 is the MSB, right. Now we'll see the truth table. Now we'll form the truth table. From the truth table we can go for the Boolean expression. By using the Boolean expression we can implement with the logic gates, right. So this is the input code is the BCD code, D0, D1, D2, D3. Output is the gray code, G0, G1, G2, G3, right. So we are taking from 0, 0, 0, 0, 0, 0, 0, 1 like that, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 9. Here also number is there, 1, 0, 0, 1. So up to 9 we consider. Input is taken from normal BCD code, that is every digit is represented by 4 digits, right. So we are having 0 to 9, above 9 is not considered. So now the 0, 0 is converted into gray code by using the above logic. So here also 0, 0, 0, here 0, 0, 1, 0, 0, 1, 1. We need to perform the BCD. We need to convert this BCD into gray code using the above logic. Now we'll see one example. 0 is written as it is. 0 to 0 is again 0 only. 0 and 1 both are different means 1. 1, 0 both are different means 1. Right. So that 0, 0, 1, 0 BCD code, the equivalent gray code is 0, 0, 1, 1. Like that the other codes are converted. Now we got the truth table, right. We have got the value of G0, G1, G2, G3. So by using the Karnaugh map we need to identify the minimized Boolean expression for G0, G1, G2 and G3. See this G0 having 1, 2, 3, 4, 5 ones are available. G1 1, 2, 3, 4, 4 ones are available. G2 1, 2, 3, 4, 5, 6 ones are available. The G3 1, 2, the 2 ones are available. So based on this value we need to plot the Karnaugh map for these 4 digits. Then we need to find the minimized Boolean expression. Now we'll go to the Karnaugh map for a simplified Boolean function. So first we will see the G0, right. First we will see the G0. So what is the input? Input is nothing but BCD code, D3, D2, D0, D1, 4 variables. So this is a 4 variable K map. D3 and D2 is represented in the vertical manner. D0 and D1 is represented in the horizontal manner. D3, D2 having 2 digits. So 4 combinations are available, 0, 0, 0, 1, 1, 1, 1, 0. So there is an interchange between third and fourth row. Similarly D0, D1 having 2 digits. So we have 4 combinations are available, 0, 0, 0, 1, 1, 1, 1, 0, right. Now the inputs are marked. So what is this first cell? First cell is 0, 0, 0, 0. Second cell is 0, 0, 0, 1. Now we can mark the 1 in the Karnaugh map. For a G0, 1, 2, 3, 4, 5 ones are available. Already we discussed in the truth table. There are 5 ones are available. And also we marked up to 9. 10, 11, 12, 13, 14, 15 are not considered. So that is taken as a don't care conditions, right. So using min term these cells are represented as this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is a min term representation. So based on that, so this is the 10, this is 11, 12, 13, this is 14, 15. These cells are marked as the don't care conditions, right. Now we'll go for the grouping of the cell. So while grouping we can take it to the account of the don't care condition, but it is not necessary to all group all don't care condition. If we are needed we can take the don't care condition while grouping. So if we are not needed we can leave it as it is. So based on that, 1, 2, 3, 4, 5 ones are available. So these 3 ones along with the don't care condition is grouped together. These 2 ones along with this another 2 don't care conditions are grouped together. Right. First we'll see this grouping. So while grouping this 4 cell, we need to refer the corresponding row. While referring corresponding row, 0, 0 cancelled by 1, 1, 0, 1 cancelled by 1, 0. So all are got cancelled. So only we have to refer the second column. So it is available in the second column. What is available here? 0, 1. The first is 0, second is 1. That is, first is D0. So the D0 means 0 means D0 dash and 1 means D1. So 0 represented by so D0 dash and D1. D0 dash and D1. Right. Now to refer the second grouping. Here also we have to refer the corresponding row, but corresponding rows are cancelled. Only we have to refer the corresponding column, fourth column. Fourth column is 1, 0. 1, 0 means D0, D1 dash, right? D0, D1 dash, right? Here what we got? D1, D0 dash, here D1 dash, D0. So what is this value? This is nothing but a XOR gate. D1 XOR of D0. So by using the single XOR gate, we can perform this operation. So this expression is equivalent to the XOR gate, right? Now we'll go to the next digit G1. So again it is a 8 variable K map. D3, D2, D1, D0 is the inputs, right? 1, 2, 3, 4. There are 4 ones are available. The remaining these 6 are don't care conditions, right? So these 4 ones, these 4 cells are grouped together. These 2 1 and these 2 don't care condition we get taken into account. Similarly, while grouping these 2, we are taking these 2 don't care conditions also, right? So the top and bottom cells are grouped together, right? So while grouping 4 cell, we will get the minimized Boolean expression. So that we are taking this don't care condition also into account. So while grouping these 4 cells, we have to refer the corresponding second row and third row, right? What is available in the second row? 0, 1, 1, 1. This 0 is cancelled by 1. Only this 1 is available. The second digit 1 is available. What is second digit? D2. Second digit is nothing but D2. Similarly, the corresponding first column and second column we have to refer. 0, 0, 0, 1. So the first digit 0 available in both the column. Here 0 is second digit, here 0 is available, here 1 is available. So the got cancelled. Only the first digit is available. What is first digit? D1. 0 means D1 dash, right? So D2, D1 dash. So we'll grouping these 4 cells. Now we'll group these 4 cells. So we have to refer the corresponding first row and last row. What is available in first row? 0, 0. Last row 1, 0. So the first digit here 0, here 1 got cancelled. Second digit is 0, here also 0, right? Second digit means D2. 0 means D2 dash, right? So corresponding third column and fourth column we have to refer. Third column is 1, 1, here 1, 0. So the first digit 1 is available in both the column. The second digit here 1, here 0. So this 1 and 0 got cancelled. So only the first digit is 1, right? What is the first digit? D1. So it is D1. D2 dash D1, right? So D2 D1 dash plus D2 dash D1. Again it is nothing but very equivalent to the XOR gate. Equivalent, the expression is equivalent to XOR gate. So that D2 XOR of D1, right? So we got the expression for G0 and G1. Now we'll go to G2 and G3. So for this G2, 1, 2, 3, 4, 5, 6. There are 6 ones are available. We already discussed in the truth table. These 6 are don't care conditions, right? So while grouping, we are grouping these 8 cells. While grouping 8 cell, the Boolean function will be minimized. We will get the minimized expression. Similarly, these 8 cells are grouped together. I already told this don't care condition while grouping we can use it. But at the same time, if it is not grouped by the don't care conditions are not grouped, that is not a problem, right? So while grouping 1, we can use this don't care condition. So based on that, these 8 cells are grouped together and these 8 cells are grouped together. So first we'll consider these 8 cell green color. So the corresponding second row and third row we have to refer. 0, 1, 1, 1. So first digit is 0, here 1 got cancelled. Second digit is 1 available in both the row. What is the second digit? D2. So it is D2. See, this only one variable we got while grouping 8 cell. If we group 4 cell, we got 2 variables. Right? Grouping of 8 cell, we got only D2. The corresponding columns are got cancelled. 0, 0 cancelled by 1, 1, 1, 0, 1 cancelled by 1, 0. Now we'll see the grouping of these 8 cells. Second row, third row and fourth row. What is available in third row? 1, 1, 1, 0. The first number 1 is available in both, but second number is 1, 0 got cancelled. Only the first number is 1. What is first number? D3. Right? So it's D3. So here we have D2 plus DT. We have the simplified expression D2 plus D3. Right? Now we'll go to G3. G3 having only 2 ones. These 6 are don't care condition. So we are grouping all these 8 cells. You have to refer the corresponding third row and fourth row. What we discussed similar, same thing. So the first digit is 1, 1 commonly available. Second digit is 1, 0 got cancelled. What is the first digit? D3. Right? Similarly what we discussed here, same D3. So G3 equal to D3. Now we got the minimized Boolean expression for G0, G1, G2 and G3. Now we'll implement this Boolean expression using the logic gate. Now we'll go to the logic gate. So this is the BCD code. The BCD code D3, D2, D1 and D0. Right. So this is the gray code, output gray code. Right. So 4 inputs are available. According to our requirement, we can connect. For G0 and G1, we already discussed, we are having XOR gate. By single XOR gate, we can get the output gray code of G0 and G1. G0 is nothing but D1 XOR of D0. Right. So we are connected D0 and D1. So we got D1 XOR of D0, that is nothing but G0. G1 is D2 XOR of D1, D2 and D1. Here D1 and D0, here D1 and D2. Right. So the D1 and D2 is connected. So that we got the D2 XOR of D1, that is nothing but G1. What is G3? G3 is nothing but D2 plus D3. So we are using one OR gate to add D2 and D3. So here D3 and D2 is connected. We got D2 plus D3. G3 is nothing but simply D3. So the tapping is taken from D3. Right. So this is the BCD code. By using the logic gate, the corresponding inputs are connected. We got the gray code, output gray code based on this expression obtained from the K map, G0, G1, G2 and G3. So in this video, we discuss how to convert BCD code into gray code. What is the logic? What is the logic we are using? From that, we develop the truth table. From the truth table, using K map, simplified Boolean expression is obtained. That Boolean expression is implemented with the logic gates. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers, in this video we will see the gray code to BCD code converter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, gray code to BCD code converter. First we'll see how to convert the gray code into BCD code. Let us consider the gray code 110101. So this is the given gray code. We are going to convert into BCD. What is the process? Write the first digit as it is. The first digit is written as it is. Then perform the XOR operation of this first digit with the second digit. So see the arrow mark, this one and this one. We have to perform the XOR operation. What is XOR gate? XOR gate is given here. Truth table of XOR gate is given here. AB the input, C is the output. There are 4 combination. AB 2 variable, 4 combination 0 0 0 1 1 0 1 1. 0 0 mean the output will be 0. 0 1 mean output will be 1. 1 0 mean the output will be 1. 1 1 mean output will be 0. So from this we can easily identify that if the inputs are both are equal, whether 0 0 or 1 1, the output is 0. The inputs are different, that is 0 1 or 1 0, the output will be 1. So XOR gate, the output or the nature of the output is both the inputs are equal, the output is 0. Both the inputs are different, the output will be 1. So based on that, we can perform this XOR operation, right? In the gray code, first digit is written as it is. That is the first digit of the BCD. Now first digit of BCD is performed with the second digit of the gray with the XOR operation. See here also 1, here also 1, same. The inputs are same, so the output will be 0. Then this 0 is performed with this 0. So again the inputs are equal, so the output will be 0. Then 0 and 1. 0 and 1, the input both the inputs are different, mean the output will be 1. Now 1 and 1, again the inputs are equal, so the output is 0. Then 0 and 0. Now also the inputs are equal, so the output is 0. Then 0 1. 0 1 means the inputs are different, so that the output will be 1. So the resultant BCD code is 1 0 0 1 0 0 1. Right? This is the gray code now converted into BCD. Right? So what is the process to convert the gray code into BCD? This is the given gray code. First digit is written as it is. That first digit is performed with the second digit of the gray code with the XOR operation. Like this, that operation is performed. Finally, we got the BCD code. The nature is both the inputs are equal means 0, both the inputs are different means the output will be 1. So based on that, we got the BCD code. So in this, we will frame the truth table for gray code to BCD code converter. In this, the input code is gray code G3, G2, G1, G0. G0 is the LSB, G3 is the MSB. Similarly, the output code is BCD, B3, B2, B1, B0. B0 is LSB, B3 is MSB, right? So with this notation, we'll go for the truth table of the gray code to BCD code converter. We'll go to the truth table. Now this is the input gray code G0, G1, G2, G3. This is the BCD B0, B1, B2, B3. Right? We are converting gray code to BCD. Right? So here 4 variable 1, 2, 3. So 16 combinations are available. Here also 16 combinations are available. 0, 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0. So here correspondingly this 0, 0 is converted into BCD. Similarly, the 0, 0, 1 is converted into BCD. Right? So first 0, all 0 means here also 0. Here 1. 1 1 means 0 0 1 0. 0 0 1 0 means 0 0 1 1. Right? So based on the above process, gray code is converted into BCD. Here, so here this is not in a order. Normally we will write 0 0 0 1 1 0 1 1, but it is written as 0 0 0 1 1 1 then 1 0. Right? Here the order is changed. In why we changed this order? In order to bring the in a sequential order in a output. See this here, the output is 0 1 0 1 0 1, like that it goes for B0. B1 2 zeros and 2 ones, 2 zeros and 2 ones. B2 is first 4 zeros, remaining 4 are ones. B3 is first 8 is 0, remaining 8 is 1. So it is in a sequential order. In order to bring this order, this side the order is changed, nothing else. We can go with any order. Here also we can bring the same order in a sequential order, so that we will get the BCD. Right? So here order is changed in order to get this BCD code in a sequential order, in a particular order. Right? So that is the difference. So it is very important that here the codes are not written in a order. It is in a interchange. Order is interchanged, but this side the order is in a uniform order. While changing this order in the while interchanging the gray code order, we are getting the BCD order in a uniform manner. Right? So we have 4 digits are available. Now we need to find the Boolean expression, minimized Boolean expression for this B0, B1, B2 and B3 by using the Karnaugh map, so that minimized expression can be implemented with the Boolean logic, with the logic gates. Right? So we will go to the Karnaugh map to simplify this B0, B1, B2 and B3. See this B0, we have 0, 1, 0, 1 like that. So that there are 1, 2, 3, 4, 5, 6, 7, 8 ones will be available. Similarly, B3, 2 zeros, 2 1. So here also 8 ones are available. Here first 4 zeros, remaining 4 are 1. So here also 8 ones are available. Here first 8 is 0, remaining 8 is 1. So here also the 8 zeros are available, right? So both, all 4, B0, B1, B2, B3, there are 8 ones are available. Now we'll go to the Karnaugh map to bring the simplified Boolean function. So the Karnaugh map, K map for binary output and get the simplified expression. First we'll go for the term B0, the LSB. The term LSB, we'll see that. So what is the input? The gray code is the input. G3, G2, G1, G0. This is the, these 4 are input. So this is a 4 variable K map. G3, G2 is assigned in a vertical manner. G1 and G0 is assigned in a horizontal manner, right? G3, G2, 2 variable having four possible options, 0, 0, 0, 1, 1, 1, 1, 0. There is a interchange between third and fourth row. Similarly, G1, G0 is 2 variable, so having 4 combinations, 0, 0, 0, 1, 1, 1, 1, 0. Here also third and fourth column is interchanged. Now we have to mark all the ones. We already discussed there are 8 ones are available. 1, 2, 3, 4, 5, 6, 7, 8 ones are available. That is circled by the red color. Remainings are zeros, right? Here next we need to go for the grouping of the cells. Here there is no possibility of any grouping of cell. All are available individually, right? So there are 8 different expressions are available. 1, 2, 3, 4, 5, 6, 7, 8 expressions are available. So how will you write this? First refer this one. This one means you have to refer this 0, 0 and 0, 1. That is 0, 0, 0, 1. That is the first term. 3 zeros and 1. 3 zeros means G3 dash, G2 dash, G1 dash and G0. That is 0 represented by the complement. So 0, 0, 0, 1. Right. Similarly, we'll go for the next term. Next term is 0, 0, 1, 0. First 2 0, then 1 0. 0, 0 means G3 dash, G2 dash, then 1. 1 means G1. Again 0, G0 dash. Right. Like that, we can write all 8 terms. Right. Then we'll go for the simplification. Right. In an analytical manner, we'll go for simplification because it is very difficult to implement these 8 terms. Right. So G3 dash and G2 dash is taken common from first term and second term, right? G3 dash and G2 dash is taken out, right? So while taking, what will happen? What is available? G1 dash, G0, G1, G0 dash, right? This is available. G1 dash, G0, G1, G0 dash. So that is nothing but XOR gate. That is equivalent to the XOR gate, right? Then G3 dash G2, G3 dash G2 from third and fourth term is taken out. From third and fourth term, we are taking the G3 dash and G2. What is available? G1 dash, G0 dash, here G1, G0. What is G1 dash G0 plus G1, G0? That is nothing but exclusive NOR gate, right? Exclusive NOR gate. For that, we are taking one complement so that it become exclusive OR gate. Again, it become the exclusive OR gate, right? Then we'll go to G3 and G2. It taken from this fifth term and sixth term. While taking G3, G2, what is available? G1 dash, G0, G1, G0 dash. Again, it is a XOR gate. G1 XOR gate of G0, right? Then G3, G2 dash is taken out from the seventh and eighth term. What is available here? G1 dash, G0 dash, G1, G0. So this is nothing but exclusive NOR gate, G1 exclusive NOR of G0. But again, we are taking one complement, so it becomes the exclusive OR gate, right? So now these 8 terms now become the 4 terms. We are taking the common terms outside, right? See this G1 exclusive OR of G0. Here also G1 exclusive OR of G0 is available. First term and third term is commonly available, so that's taken outside. So what is available here? G3 dash, G2 dash. Here G3, G2, right? The common term is taken outside, so the remaining terms are written. Similarly here G3 dash G2, G3 dash, that is G1 XOR of G0 the whole bar. These two terms are available commonly. Third and fourth term taken outside. While taking this common term, what is remaining? G3 dash G2, G3 G2 dash. This is commonly available. This is taken outside, so the remaining term, right? So what is this G3 dash G2 plus G3 G2? Again, it is nothing but exclusive NOR, but it is written as exclusive OR with a complement. G3 exclusive OR G2 with a complement. Similarly, this G3 dash G2 plus G3 G2 dash. This is nothing but directly we can write it as exclusive OR gate. G3 exclusive OR of G2. Right. Now see this, what is available here? We take this is A, this is B, this is A, this is B. So it is nothing but A, B bar plus A bar B. Right. So this is nothing but again a exclusive OR gate. Right. You assume that this term is A, this term is A bar. This term is B, this is B bar. Otherwise, this is B, this is B bar. That is A, B bar plus A bar B is nothing but again a exclusive OR gate. So that G3 exclusive OR of G2, exclusive OR of G1, exclusive OR of G0. Right. So finally, we got with a exclusive OR gate with 4 inputs G0, G1, G2, G3 will give the term B0. Right. This is the gray code, this is the BCD code, right? So after simplifying expression, we got a simplified way. Only we need a XOR gate with 4 inputs, so that we'll got B0. Now we'll go to the B1. The next term will go to the B1. Right, B1 is there. So again the 4 variable K map is available here. 8 ones are marked together, 1, 2, 3, 4, 5, 6, 7, 8. So here the possibilities are available. We have grouped these two cells, these two cells, these two cells and these two cells. So there are 4 groupings are available. So while grouping these two, we have to refer the corresponding first row, third column and fourth column. What is available in first row? 0, 0. 0, 0 means G3 dash, G2 dash, G3 dash and G2 dash, right? G3 dash, G3 dash, G2 dash. So this is the third term, G3 dash, G2 dash. Then third and fourth column, 1, 1, 1, 0. This 1 is available commonly. This 1 and 0 is cancelled. Second 1 and 0 is cancelled. So first one is available. First one means G1. So G3 dash, G2 dash, G1, right? So this is the minimized expression for the first grouping of first 2 cells. Now we'll go to the second, this grouping of second grouping. So what is available here? 0, 1. 0, 1 means G3 dash, G2, G3 dash, G2, right? What is available corresponding the column, first column and second column? 0, 0, 0, 0. First 0 is available in both. Second here 0 is available, here 1 is available, got cancelled. So here we have 0. 0 means G1 dash, right? G1 dash, G3 dash, G2, G1 dash. So this is due to the second grouping. Now we'll go to the third grouping. Third grouping, what is available? 1, 1. 1, 1 means G3, G2, G3, G2. What is available correspondingly here? 1, 1 and 1, 0. The first one is available commonly. First one means G1. So G3, G2, G1, right? Then the fourth, last grouping, 1, 1. That here 1, 0 is available. 1, 0 means G3, G2 dash, G3, G2 dash. What is available corresponding first column and last second column? 0, 0, 0, 1. It's the first 0 available commonly. This 0 is cancelled by this 1. So 0 means G1, right? So it is G1 dash, right? G3, G2 dash, G1, G1 dash. So this is the expression. So here also we'll go for simplification. We'll take G1 dash commonly. We will take the G1 dash commonly. Side. So it is available from first term and second term. While taking G1 outside, what is remaining? G3 dash, G2, G3, G2 dash. So again this is nothing but a exclusive OR gate, right? From this G1 is taken outside. G1 is available from third term and fourth term. So what is remaining? G3 dash, G2 dash, G3, G2, right? This is nothing but exclusive NOR gate, but here wrote exclusive OR gate with a complement. So both are equal. Exclusive NOR gate with complement is exclusive OR gate. So again take this is A, this is A bar A, this is B B bar. So that A bar B plus A B bar, that is nothing but again exclusive OR gate, G1, G2, G3. Right. So finally we need only one XOR gate with 3 inputs G1, G2 and G3. So that will get B1. In previous B0 what we have? Same XOR gate with 4 inputs G0, G1, G2 and G3. Here 3 inputs. Now we'll go to the next one, B2. So B2 again 8 variable K-map available. There are 8 ones are available. 1, 2, 3, 4, 5, 6, 7, 8. Right. So we have two groups. These 4s are grouped together. These 4 ones are grouped together. Right. So while grouping these 4 ones, we have to refer the corresponding the second row 0, 1. 0, 1 means G3 dash G2. G3 dash G2. Right. All columns are cancelled. 0, 0 cancelled by 1, 1. 0, 1 cancelled by 1, 0. Now we'll see grouping of these 4 cells. Again all columns are cancelled, only we have to refer the fourth row 1, 0. It's available correspondingly 1, 0. 1, 0 means G3 G2 dash, G3 G2 dash. Right. So G3 G2 dash plus G3 dash G2. Again it is nothing but a XOR gate. Right. This is nothing but XOR gate with 2 inputs G3 and G2. Right. So B0 we have 4 inputs, B1 we have 3 inputs, for B2 we have only 2 inputs. In all the cases we need a XOR gate. XOR gate with 4 input, 3 input, now have only 1 input. Right. Only 2 inputs. Right. So all 3 cases we need XOR gate with 4 input, 3 input and 2 input. Now we'll go to the B3. There are 8 ones are available. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. So here all 8 cells are grouped together. So here the possibility is to group 8 cells. Right. So while grouping 8 cells, the corresponding columns got cancelled. All are cancelled. You have to refer the second, third row and fourth row. 1, 1, 1, 0. So the first one is commonly available. Second one is cancelled by this 0. What is the first one? Is nothing but G3. So B3 equal to G3. Right. Now we got the expression for all B0, B1, B2, B3. Right. Now we'll implement this expression in a logic gate. So the simple logic gate is available. So this is a gray code G0, G1, G2, G3 input. This is a binary code B0, B1, B2, B3. We already discussed the B0, B1 as well as B2. What we need is XOR gate. Right. So B0 having 4 inputs G3, G2, G1, G0. B1 having 3 inputs G3, G2, G1. B2 having 2 inputs G3 and G2. B3 is nothing but simply G3. So by G3, so G3 is connected directly to B3. Right. B3 is directly G2. Right. Now see this G3 is connected here and G2 is connected. So we have G2 and G3. So G2 XOR gate of G3 XOR gate of G2 will give the B2. Right. So this G3 and G2 is connected to another XOR gate. So here we available G3 and G2 and G1 is connected. So we have G1, G2 and G3. So here 3 inputs. So we'll get the B1 equal to XOR of G3, G2, G1. Now this output is given to another XOR gate. So what we have G3, G2, G1 and G0 is also connected. So totally we have 4 inputs G0, G1, G2, G3. So it will perform the XOR operation with 4 inputs. So we got B0 equal to G3 XOR of G2, XOR of G1 and G0. Right. So we'll got all 4 digits B0, B1, B2 and B3. So this is the output BCD code. Right. So B3 is connected directly. For B2, G1 and G3 is connected. This G3 and G2 is connected to another XOR gate with G1. So we got these 3 output. These 3 output is connected with another XOR gate with G0. So we got 4 output. Right. 4 variable XOR gate. So in this video we discuss about how to convert gray code into BCD code. First we will see what is the process to convert gray code to BCD code. From that we develop the truth table. In the truth table, using the Karnaugh map, we got the simplified expression for the BCD code. That simplified expression is implemented with the logic gates, so that we can convert gray code into BCD code. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.